Okay, thank you. Welcome back to the last technical session of the Crescent High-Res workshop. In this session, we have 4 other speakers, and they will talk about operational planning in microgrids. The first speaker is Dr. Consalva Msigwa. She is a researcher and lecturer of electrical engineering at Dar es Salaam Institute of Technology. She strives for high-quality engineering education as well as research, innovation, and commercialization. Her current research works include solar treatments of biomass for power engineering using carbon slurries in hybrid renewable energy systems, education for renewable establishment of Renewable Energy Technologies Center funded by the Royal Academy of Engineering, and enhancing the knowledge and skills for the graduated engineers at Renewable Energy Technology Center funded by the Royal Academy of Engineering. Her research interests include power electronics applications, renewable energy, and electric power systems. Now let's listen to Consalva's presentation. Natalie, can you please share the video?
Good afternoon, ladies and gentlemen. My name is Consalva Msigwa, lecturer of electrical engineering at Dar es Salaam Institute of Technology. I'm presenting to you the development of a scalable hybrid renewable energy-based microgrid for remote and rural areas, the case of Tanzania. I take you through the introduction, access of electricity in rural Tanzania, and the integration of renewable energy-based power plants. Notable progress has been made on energy access in recent years, with the number of people living without electricity dropping to roughly 840 million from 1 billion in 2016 and 1.4 billion in 2010, as indicated in Rwanda. However, the large population, about 573 million of people without electricity, reside in sub-Saharan Africa. Thus, efforts must be done so that the 840 million have access to electricity by 2030, as stipulated in SDGs number 7. Access of electricity in rural Tanzania in 2016 was about 32.8% of population, as indicated in the map, where the northeastern part of the country through Dar es Salaam to southwestern part has the access electricity from the grid power network, leaving the vast area of the country without electricity. However, as we speak now, Tanzania has 74% of population having access to electricity, as indicated in All Africa News magazine, accessed on February 15th, 2020. Initiative to increase the access of electricity are by using small-scale renewable energy power generating systems, such as solar PV system, wind turbine power system, and main hydropower generating stations. The diagram here shows the main hydropower plants. The bottom we have biogas system, and to the right we have a solar PV system. All these technology are capable of generating power in few kilowatts, enough to supply a group of consumers. It was found out that the designs of these technologies is on current demands and the supply, with little attention to future increase in demand, as well as increase in population likely to occur within the technical lifetime of the operation being implemented. The designs were aimed for small household demand, thereby causing limitation to enterprises and other potential larger users of electricity in rural communities. The diagram here shows the gentleman using a smart box, a solar lantern, to charge his mobile phone. The lantern, which is used to supply light during the night time. The bottom we have a DC powered sewing machine, and to the right we have the gentleman attending to a PV module installed in the roof of the house, and we are told here that it is a 2000 watts, enough to power 5 households. To increase the volume of power generation, small-scale power generation system can be integrated to form a hybrid system. The system uses power electronic converters, AC-DC, DC-DC, DC-AC, and energy sources interface to the power system depending on the network requirements. For inverters, appropriate power pass with modulation switching scheme and passive filters are used to minimize harmonics that can be generated during switching processes. The figure shows the multi-source electric power generating system comprising different renewable-based power stations on one side and the loads on the other side. The output of renewable energy-based power plants is variable. As a result, management of dynamic power balances, power flow, and the network voltages profile imposes unique challenges in the context of microgrid. For interfacing and the control of the microgrid, the controller for AC, DC, 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 AC converters are designed to enable to get the desired controlled DC at a regulated voltage DC bus. The sum of DC power on the DC bus is increased power to allow the more consumers to be connected to such power network. DC loads are connected on the DC bus bar, and in case of AC loads, DC power is converted to AC power using DC AC converters to power the microgrid AC loads. The AC loads can be connected to grid network in case of this power generation. In case of inadequate power in the DC bus bar, the storage battery will supply power to the DC bus bar. Apart from the PhD working on this project, we have three research assistants having the following sub-projects. The first student is working on the dynamic modeling and control of small-scale permanent magnet synchronous generators based wind turbine for grid-connected and off-grid applications. He is working on the issues related to problems of synchronous of wind turbine speed and generator speed. The second student is working on the sub-project titled Modeling Voltage Sourcing Data and Stable Integration of Renewable Energy into Grid. He's working on the issues of stability during integration of renewable energy to grid network. The study student is working on sub-project titled Active Power Filter in Renewable Energy Based Power Generation System Supplying Island Mining Grid. And she is working on the issue related to harmonics in the microgrid due to switching of power supplies as well as due to non-linear flows. The power in the DC basic bar is the sum of individual powers from renewable energy based power stations plus the power from the storage battery. And in full power network, the power at sending end must be equal to the power at receiving ends. Thank you for listening, and you are most welcome to Tanzania.
Okay, thank you very much, Consalva, for your nice presentation. Can you please unmute your mic? Consalva, can you hear me?
Yes.
Okay, thank you for your nice presentation. I have a question about needed data sets for your study. Do you have sufficient data for undertaking your study?
Yes, we do have the sufficient data for undertaking of our study. Most of the data we need is the power quality of the generated power. We were most interested in knowing the magnitude of the voltage and the frequency as well as the waveform profiles. We would like to have for us, for single phase, we usually has the voltage level of 240 volts, frequency of 50 hertz, and we are for a sine wave for frequency and the voltage as well. So when we go to collect data, we most of the time collect that, interesting in improving the power quality. We will also interested in, but it's like an addition to knowing how the community are benefited to power being supplied to them, and challenges related to the power supplied to them from the renewable energy technologies available in the particular area.
Okay, thank you. There is another question from Elizabeth. Is the microgrid that you presented has been applied in rural areas? If yes, how was the acceptance of the community and how operate and maintain the grid?
I have presented the microgrid, Scalable ones, The one I presented have got 4 sources of renewable energy power generation station, but the common one with the hybrid system we do have in the community or in the application currently consists of 2 sources. Most of them we have the hybrid system of wind and the solar, or solar and gasification systems. Both of these systems are operating. We have the common one is found in Lukmanda village. We have visited the place twice. People are enjoying having the facility at their place, though not all households are connected to the power plants because of now the financial situation of individual families. But well, people are enjoying having such stations at their places, and they benefit from they use the power generated from these microgrids to work with to supply for their small scale business such as salons, wedding facilities, and the small shops, things like that.
Okay, thank you. I have another question about the largest microgrid in your country. Do you have any idea?
Not recently, I heard that the government is currently has some bigger project starting from 5 megawatt solar PV power stations. The government is aiming in having the hybrid system comprising the solar and the generator set systems, which are currently being used to supply electricity to most of rural villages or rural communities. The government nowadays currently is building such power systems to most of our districts, aiming in phasing out using of diesel as the source of energy in most of remote rural area not connected to grids. Earlier, we had the diesel power stations commonly used everywhere in the areas not connected to grid, but now it's very expensive. Plus, the diesel thing pollutes the environments.
Okay, thank you. There is another question from Cheng. The question is, from your experience, what's major productive use of electricity for microgrids in Tanzania?
Yeah, productive use is like now the country, the government has the vision of having industrialization. So the government is encouraging of having modern energy in everywhere in the country to enable peoples throughout the country to engage in small scale business. So it starts with small power plants, others use it to for in the deep rural areas, they use it for wedding and carpentry and the small shops. But in districts, centers, you find people engaging themselves in small factory, generating, like now we are not allowed to use plastic bags. So others has got factories which manufactures bags which are not plastics, things like that.
Okay, thank you very much for your nice presentation.